Welcome to the Unit 14 Section 3 video on solving absolute value functions. To solve an absolute value equation, isolate the absolute value expression, set the quantity inside the absolute value notation equal to both the positive and negative of the quantity on the other side of the equation, then solve both equations and check your solutions. So for this example, we have an absolute value expression already isolated, so we're going to split it up, setting it equal to negative 14 and positive 14, and then we'll solve each one independently, getting x equals 3 for one, and x is equal to negative 19 over 3 for the other. So our solution set would be negative 19 over 3 and 3. For this example, we have to isolate the absolute value first, so we're going to add 10 to each side. Then we will set the absolute value expression equal to negative 42 and positive 42, and then solve each one independently, getting x equals 7 and x equals negative 5. So our solution set would be negative 5, 7. In this example, we have to isolate the absolute value first by subtracting 2 from each side. Then this is the point where we will split up our equation into two parts. But if you notice, we have an absolute value expression equal to a negative number, which cannot happen. We cannot have an absolute value of something equal a negative number because the absolute value of anything is going to become positive. So we would have no solution since an absolute value function cannot equal a negative number. So you would just simply write no solution. For this example, first we're going to subtract 8 from each side, then we're going to divide by negative 4 so we can isolate our absolute value expression. Then we'll split it up into two parts, setting it equal to negative 13 and positive 13. In the first, we subtract 3 from each side, then divide by 10 to get negative 16 over 10. On the other, we subtract 3 to get 10x equals 10, so x equals 1 when we divide each side by 10. So our solution set would be negative 8 over 5 and 1. To solve an absolute value inequality, isolate the absolute value expression, use the quantity inside the absolute value notation with the original inequality and the original quantity on the other side, and with the opposite of the original inequality and the opposite of the quantity on the other side. Then the two simpler inequalities form either a union if the absolute value is greater than or equal to a quantity, and an intersection if the absolute value is less than or equal to a quantity. So, for example, if you have an or statement, you're going to use a greater than. If you have an and statement, you're going to use a less than. I like to use the little expression Goreland. It's your favorite Halloween theme park, Goreland. G or gore, greater than for or. Land, L, and, less than for and. So you can use that little device to help you remember greater than for or, less than for and. So let's take a look at an example. Here we have an absolute value expression greater than or equal to 12. It's already isolated, so we're going to split it up into two statements. We have x plus 5 is greater than or equal to 12. It's the same statement without the absolute value symbol. And then we flip the sign and change the sign. So we have x plus 5 is less than or equal to negative 12. And since we have greater than or equal to following the absolute value, greater than is going to be an or statement. So we put an or statement in between. Now we can solve the compound inequality and get x is greater than or equal to 7 or x is less than or equal to negative 17, which we can express in set notation, on a number line, and in interval notation. For this one, we have to first take our minus 8 after the absolute value and add it to each side. So it gives us the absolute value of x is less than 6. We can split this into two statements, x is less than 6 or x is greater than negative 6. And since we have a less than statement behind the absolute value, we are going to use an and statement. So in set notation, we can combine our inequalities to write it as one statement. On the number line, it would look like this. And in interval notation, we would have negative 6 to 6. For this inequality, we are going to subtract 7 from each side, then divide by 4. Now that the absolute value is isolated, we're going to write it as it is, dropping the absolute value sign. Then we're going to write it again, flipping the inequality and changing the sign on the right-hand side. And since this is a greater than statement, we are going to use an or statement in between. Now we add 10 to both sides in each inequality, and we keep our or in between, and we can write our solution in set notation on the number line or in interval notation. In this example, we have to isolate our absolute value first, so we're going to subtract 6 from each side, and then divide by negative 2, remembering to flip our inequality because we divided by a negative. Now that we have an absolute value expression by itself, we're going to split it up, and since we have a less than statement, we are going to use an and in between. Now we'll solve each inequality by subtracting 10 from each side, and we'll keep our and in between. Since we have an and statement here, we look at our inequalities and we can put our x in between negative 11. Since we're greater than negative 11 and we're less than negative 9, we can write it as one statement. We can express our answer on our number line, and we can write it in interval notation. For this inequality, we have to isolate the absolute value by multiplying each side by 2. Then we can split it up, keeping it like it is, just dropping the absolute value sign, and then writing it again, but flipping the inequality and changing the sign. And since we have a less than, we're going to use an and statement in between. Finish solving both of the simple inequalities by subtracting 8 on each side. And we take a look at our solution. We have x is greater than or equal to negative 4. We also have x is less than or equal to negative 12. An and statement is the part that's shared, but there's nothing that's shared in between those two statements. So we have the empty set, nothing on the number line, and in interval notation, no solutions or simply none. For this example, we're going to solve this inequality. It's already isolated, so we'll split it up. Then we will solve each one using an or statement in between since we are greater than. And taking a look at our solutions, we have x is greater than negative 10, x is less than 11. Since we're doing every piece as part of the solution for both of the simple inequalities, we have all solutions, all real numbers, everything shaded on the number line, and our interval from negative infinity to positive infinity. Now let's take a look at an application. A manufacturer of boat motors has specifications for parts with given tolerance limits. If a part is to be 3.2 inches wide with a tolerance of 0.01 inches, this means that it must be at least 3.19 inches wide or at most 3.21 inches wide. This tolerance limit can be expressed by the absolute value inequality. The absolute value of W minus 3.2 is less than or equal to 0.01, where W represents the width of the part. Find the maximum and minimum acceptable dimensions of a part that is supposed to be 7.32 centimeters long with a tolerance of 0.002 centimeters. So we write down our inequality. The absolute value of W minus 7.32 is less than or equal to 0.002. And then we're going to solve it. Since we have a less than, it's an and statement. And then we solve each one independently. And so we find that our tolerance limit has to be, or our width has to be between 7.318 and 7.322 centimeters. So our maximum is 7.322 and our minimum is 7.318. Now we're going to find the tolerance of a part that must satisfy the inequality. 5.18 is less than or equal to W, which is less than or equal to 5.24. So to do this, we're going to take our compound inequality and we are going to subtract 5.21 from each part so that we get negative 0.03 and positive 0.03 on either side. Then we can write it as the absolute value of W minus 5.21 is less than or equal to 0.03. So the tolerance is 0.03 centimeters. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.